Hello and welcome to KEI Industries' concept launch of Forestry Vault Australia, a new and innovative app in carbon sequestration and forestry management. Deforestation and a heavy reliance on fossil fuels has caused global carbon dioxide emissions to rise rapidly over the past few decades. The clearing of land and overuse of natural resources has caused severe land degradation, generating devastating damage to forests and their respective ecosystems. The increase of carbon dioxide in the atmosphere has triggered changes in the global temperature and weather patterns, known as climate change. As such, the growth and health of forests have been negatively impacted. Unprecedented weather patterns have escalated the intensity of natural disasters like droughts, flooding, landslides, and erosion. These factors have also seriously threatened the health and sustainability of existing forests. Carbon pollution is mostly created by the burning of fossil fuels for electricity production. This is then followed by transportation and the industry sector. Land use is another large producer of CO2 emissions, such as deforestation, degradation of soil, and land clearing for agricultural uses. Carbon pollution has the ability to affect a whole range of living things, from the environment to animals, ecosystems, biodiversity, and people. Generally, one small thing being affected first can then cause a massive roll-on effect, impacting on a whole range of ecosystems and other forms of life. So, what are the consequences of carbon pollution? Impacts on health and the vitality of forests, larger insect populations which damage trees, root and bud rots due to the spread of funguses, along with many others. The loss of biodiversity, as most trees need a stable climatic range for optimal growth, hence affecting animals, humans, and other species that rely on these resources, as animals are likely to move habitats or die, and economic stress for families. Flowering times can also change, as well as bud break, having effects on the carbon sequestration potential of trees and plants. It also affects productivity and could lead to job losses, as seen recently at the Morwell timber mill. However, reforestation and improvement of soils can have the opposite effect. We'll now look at some of the ways in which technology can be used to help manage natural resources and become part of the solution in the fight against environmental problems, including climate change. The use of technology in resource management is by no means a recent concept. Agriculture, plumbing, mining, and the controlled burning of forests are just some of the ways in which humans have used technology to get more out of natural resources. While these technologies played a pivotal role in civilization, they were mostly concerned with exploiting natural resources rather than protecting them. In many cases, these technologies have created significant environmental problems themselves. Fortunately, growing recognition of the dangers of environmental destruction has seen the development of technologies which aim to support and maintain our natural environment rather than simply exploit them. The advent of computer and information technology has allowed us to develop techniques to better understand the way natural resource systems operate and respond to change. One form of information technology used in natural resource management is Geographic Information Systems, or GIS for short. GIS produce computerized representations of spatial information combined with one or more other types of data. GIS techniques analyze geographic data particularly, allowing useful information to be plotted on a map, which is why they're sometimes referred to as geomapping. One natural resource which stands to gain the most from the use of GIS technology is forests. Because forests are often distributed over vast spaces, GIS techniques are particularly useful for analyzing and representing them. Forest data is collected from a variety of sources including forestry and park records, remote sensors, aerial photographs, and satellite imagery before being fed into a forestry GIS program. The map you see here was created from data compiled from all of the above sources, effectively charting the density of forests across the western United States. This data is made available to organisations which are able to combine it with other datasets to produce a deeper understanding of forest management issues. For example, this map produced by the US Fire Service used GIS to combine forestry and meteorological data to produce a detailed map of fire danger across the United States. While forest mapping programs in Australia have yet to reach the scale of those seen in the US, substantial progress has been made on a smaller scale. A prominent example is the urban forest map produced by the City of Melbourne. The map is a comprehensive geographic inventory of all trees within the city limits, providing detailed information on the species, health, and identification number of each tree. We want you to know about the entwined relationship between trees, forests, and carbon storage, and how that relationship changes over time. Trees store carbon for a long time. In a carbon-constrained world, that's a good thing. This process is often referred to as carbon sequestration. Now, research tells us that trees grow and store carbon in predictable ways. The amount of carbon stored in this manner also depends on the type of tree. Some trees are denser and store more carbon than others. Trees can, and often do, live in forests, including urban forests. Particular forests grow in particular places. In Australia, we call these places bioregions. Bioregions may contain many different types of forest. In Victoria, we classify collections of the same type of vegetation, for example, shrubs, trees, grasses, etc., within a bioregion according to their ecological vegetation classes. Forests can be made up of many different species. If we want to, we can grow forests of a particular type on suitable land. We know what species to plant in particular forests and when. We also know, within the bounds of statistical certainty, the amount of carbon these forests will store, as they grow, at any particular time in the future. That means by integrating our knowledge of bioregions and forest types with our knowledge of growth rates of particular species, we can estimate the growing forest's future carbon mass. It is expected in many circles that a carbon price and trading scheme is required to address the current carbon pollution problem. By introducing the variable price into our equation, we can both predict the value and carbon storing forest into the future and produce accounts of its value in incremental stages. Potential foresters can plan to plant their forests when the carbon price invokes a return of investment suitable for particular circumstances. Introducing the Forestry Vault Australia app. Forests are phenomenal ecological strongholds. They purify our air and water, maintain and preserve soil quality, and home our flora and fauna. Most importantly, as an ecological stronghold, forests fortify our ability to withstand the destructive forces of climate change. The Forestry Vault Australia app is a tool that allows for Australia to evolve and flourish in an age of uncertainty. Australia is incredibly vulnerable to the effects of climate change. The Forestry Vault Australia app presents a tool that allows for the natural environment to be engineered towards climate change adaptation, mitigation, and most importantly, climate change resilience. The Forestry Vault Australia app has a considerably wide target audience for its potential use. First and foremost, the app aims to target farms and farmers. The app provides an avenue for the conversion of farmland to forest within an economically viable framework, especially if a carbon pricing mechanism is established, rendering a conversion financially reasonable. The app also targets government bodies like local councils and catchment management authorities. Many of these government bodies have clauses within their climate change strategies for zero net emissions. Carbon sequestration through forestry presents a means to secure these objectives. Furthermore, by redefining forestry within an urban context, the app is applicable for use in metropolitan and non-rural areas, expanding the capacity for tree growth. Real-life applications could involve cultivating forests in areas that typically have little to no tree coverage, such as the western suburbs of Melbourne. The potential applications of the Forestry Vault Australia app have big implications for Australia. It has the capacity to facilitate Australia moving beyond an emissions reduction fund to an emissions trading scheme. What this means is that Australia has the potential to catch up with the big kids for carbon pricing and trading, like the majority of Europe, China, and the US. The Forestry Vault Australia app is a truly revolutionary technology. Thank you.